Hi there, my name is Adele Birkenes, and I'm a geography master's student taking Dr. Mike Mann's geospatial programming class. Today, I'm going to be sharing about my final project for the class, which was in support of my team at the USAID Geo Center. I've been a geospatial analyst there for 4 years, and over these years, my team has been working to working toward creating a geospatial enterprise system with Esri. And in 2025, we will finally roll out this system. This is our first time having an enterprise system, and so our team is still in the process of figuring out some standard protocols for uploading files. In addition to that, my team and I conducted consultations with GIS specialists who are based at USAID missions around the world to understand some of the data sets that they work with often and would like to see available in the enterprise system, as well as any sorts of preliminary analyses of the data sets that we could potentially automate for them in order to make their work easier. From all of these conversations, I decided to dedicate my project to standardizing, enhancing, and uploading data sets for the enterprise system. I specifically was interested in working toward automating the process of conducting edge matching between subnational boundary files and national boundary files. This is something that the GIS specialists struggle with often because there are usually discrepancies between the subnational boundaries they receive from their country governments and the national boundaries that the U.S. government provides. Another tool that I wanted to do was to create hex bins out of point data and automate this process. And this is because our GIS specialists work with a whole lot of point data, especially USAID activity location data, which is where USAID is implementing programs around the world. And another really common data set is ACLID, which is conflict event data. Some other tools that I wanted to build were to standardize the metadata and projections of files, and then also to simplify the process of uploading data sets or updating data sets that already exist in the enterprise system. So from those different wish list items for the enterprise system, I thought about 5 different tools and developed pseudocode for them. When it came time for actually writing the code, the output that I was able to create for this final project was specific to automating the process of creating hex bins out of point data. So that is what I'm going to be showing you today. However, I believe that this code for hex bins serves as a really good foundation and proof of concept for additional processes that could be automated as we roll out the enterprise system. So with that, I'm going to jump into a workflow, a sequence of steps that my code goes through in order to automate the process of creating hex bins. This is an overview. I'm going to jump into each step and show you what the user interface looks like as the user is interacting with the system. And in this case, I am using ACLID data for Kenya from 2014 to 2024 as the point data set. And I'm working on creating hex bins that are clipped to the boundaries of the country of Kenya. So that is what these example text boxes are referring to. So the first step is on the welcome screen, and I'm selecting the Hexbin tools. So I see the printout of the welcome message. I see the printout of the list of different options, and I select B, create hexbins out of point data. So to select it, I input B, and I receive the response, this tool, create hexbins out of your point data. So now that I've selected the hexbins tool, my next step in the code is I, as the user, am uploading the point and polygon files so that the system can check whether the files that I want to use are strictly points and polygons, respectively. So I've uploaded these two files, and I receive the confirmation messages printed out saying that my shapefiles do meet the requirements of being only points and being only polygons. So like I said, the point file is for conflict events, and the polygon file is for Kenya, and specifically the admin one or county level. So the next step is checking whether the files are projected, and if they're not projected, to project them. So for creating hexbin analyses, it is strongly recommended to conduct this in a projected coordinate system because that corresponds to linear units like meters or feet rather than coordinates in the case of geographic coordinate systems. So, so the tool takes in or is using the existing point and polygon files I uploaded, and it's checking, are they in projected or geographic coordinate systems. For the point shape file, the tool finds that it's in a geographic coordinate system, and it's not included in the text here, but it gives me a prompt to say which EPSG code I would like to use, so the user is able to enter an EPSG code corresponding to their desired projection. In this case, I entered a UTM projection that is specific to Kenya and other East Africa countries, and the projected shapefile is then saved with a new name. Similarly, with the polygon shapefile, it's also in a geographic coordinate system, and I enter the EPSG code, and that one gets saved as well. The next step from here is to take in the user's preferred hexbin size, or to calculate a default size. So I'm seeing in the tool printout that the unit of measurement for UTM is meters. And so as a user, I can input my size in meters, or I can just have the tool create the default value by dividing 2 times the total area of the polygon by the number of points in the point file. So in this case, I've selected the default option, and the printout reads that it's calculated the number of points, and it is about 11,000. And then using a search cursor, the tool is calculating the total area of the polygon shapefile. With the formula, then the default hexbin size is this stated value. So with that default value, the tool can then create the hexbins, which are saved to a shapefile that has a ending that is the integer of the size of the hexbins. And so one nice thing about this tool is that it is very easy to use it to iterate many times with varying hex bin values, and all of the different hex bin sizes will be saved with specific file names. So a user could kind of flip through lots of different hex bin sizes and possibly show the different sizes to one of their collaborators and decide on what size would be best. So after the hex bins are created, they need to be clipped to the polygon, which is the country boundary of Kenya. Again, this is given a unique file name. This is the first time that an output is being saved in a file geodatabase as opposed to just being saved as a shapefile. That is because this is the way that the clip tool works. And then finally, the last step is to add the number of points within each polygon or within each hex bin to the hex bins, and then to save that file. So in that case, it's using the summarize within tool. And the user is given a file path for their final file. And this is a quick example of what it looks like when you pull the output into Arc Pro. In this case, I used quantile classification, and so I'm sure that with more iteration, this map could be tweaked. For example, I do personally feel that the hex bins are a little bit too small. And so I would probably enter a little bit of a larger size compared to the default. But I think that this is already showing some really strong patterns that can be gleaned very quickly. And for Kenya specifically, the reason that I chose this is that I have been providing geospatial support to the country as it completes some decision making around its priorities for the next few years. And actually, the last time that the Geo Center provided similar support was in 2019. When I looked at those maps that the Geo Center provided, the ACLID conflict events were aggregated to the county level. And for Kenya, a lot of the counties are covering quite a large land area. And so I do feel that using a hex bin approach can provide more granular data to decision makers. And I think some next steps with hex bins specifically could be to also allow the user to select certain time periods that they would like to see, to select certain conflict event types, because ACLID collects anything from shootings to protests. So it could be good to make separate outputs for specific event types. And then I think another functionality that would be helpful is to allow the user to input or to summarize the conflict events to the admin 1 or admin 2 level rather than to hexagons. And I believe that because of the way that I wrote the code, it should be pretty straightforward to add these different functionalities in. And then in terms of next steps with this project more broadly, I would like to work on some of the other tools that I had in mind, including the edge matching. I think that because I had to do the standardizing, the projection in this tool for hex bins, then that code could be applied for the other tool I had in mind for standardizing the projection and metadata of data sets before they're uploaded to the enterprise system. So I think this is a pretty good start. I already shared it with some coworkers today, and they do feel that this could speed up some of their workflows. So yeah, that's that. And